When performing a load calculation for a student dormitory, the National Electrical Code, or NEC, does not consider a dorm room to be a dwelling unit. This distinction is important because it affects how you calculate the required service size for the building. According to the NEC section 220.32 subsection A, a dwelling unit is defined as an individual residential occupancy unit having one or more rooms for living, sleeping, cooking, and eating. Dorm rooms, while providing spaces for living and sleeping, typically lack permanent cooking facilities. Because a dorm room is not classified as a dwelling unit, you cannot directly apply the demand factor table found in NEC section 220.32 for determining the service size. Instead, you will need to use a more detailed approach that considers the specifics of the electrical loads within the dorm and the building as a whole. The first step in this process is to determine the total connected load. This involves calculating the total electrical demand of all appliances and equipment that will be present in each dorm room. Be sure to include lighting fixtures, the heating and cooling units, microwave ovens if provisions are made for them, and any other electrical devices students are likely to use, such as computers, televisions, and small appliances. After calculating the total connected load, you must determine the non-simultaneous loads. These are loads that are unlikely to be used at the same time. For instance, in a typical dorm room, the lights and the microwave oven might not be used simultaneously. Identifying non-simultaneous loads is crucial for a more accurate load calculation. Next, you will apply diversity factors to the calculated non-simultaneous loads. Diversity factors account for the probability that not all electrical equipment will be operating at their maximum demand at the same time. The NEC does not provide specific diversity factors for dorm rooms. Therefore, you will need to rely on your engineering judgment and experience to estimate reasonable diversity factors. This estimate should consider the usage patterns of students, the type of equipment they are likely to use, and any restrictions or controls on electrical usage within the dormitory. Finally, to calculate the required service size, sum the calculated non-simultaneous loads after applying the appropriate diversity factors. This sum represents the estimated maximum demand for each dorm room, which you can then use to determine the total service size required for the entire dormitory building. Keep in mind several additional considerations during this calculation process. Allow for future expansion and the addition of more electrical loads. Students' electrical needs may change over time. It is wise to provide some extra capacity in the electrical system to accommodate future demands. Consider the potential for multiple appliances or equipment being plugged into a single receptacle. Dorm rooms are often small spaces, and students may use power-stripped or multi-outlet adapters to connect several devices to a single outlet. Ensure that the wiring is sized appropriately to handle the potential load on each receptacle. It is critical to ensure that the wiring is appropriately sized for the expected load. This will help to prevent overheating, voltage drops, and other electrical problems that can arise from undersized wiring. To reiterate, dorm rooms are not considered dwelling units under the NEC, and the demand factor table in section 220.32 is not applicable for load calculations. Instead, you should perform a detailed calculation considering the connected load, non-simultaneous loads, and diversity factors. This approach will provide a more accurate estimate of the required service size and help to ensure the safety and reliability of the electrical system in a dormitory. When calculating the electrical loads, make sure to account for any specific local codes or regulations that may be in effect. Some jurisdictions may have additional requirements or guidelines for electrical installations in dormitories. Consult with a qualified electrical engineer or inspector to ensure compliance with all applicable regulations.